Hello everyone, welcome back to my channel. In today's class we will discuss about relation between hyperbolic function and trigonometric function. As I have written before the video, just because to wind up this topic. So as we know, here I have written that x belongs to R. So for the e to the power of x, the Taylor series formula I have written as 1 plus x square upon 2 factorial plus x cube by 3 factorial plus x to the power of 4 upon 4 factorial plus x to the power of 5 by 5 factorial and so on. So this is our first equation. In this equation, if you see the second one, there is a difference which is nothing but I have replaced x as ix. So here write it as put x is equals to ix. So after substituting the value of x as ix, I got this equation. So I just replaced the values of x in the equation 1 as ix. So after replacing, I got the equation as e to the power of ix plus ix is equals to 1 plus ix plus I square x square by 2 factorial plus I to the power of 3 x to the power of 3 by 3 factorial plus I to the power of 4 x to the power of 4 by 4 factorial plus I to the power of 5 x to the power of 5 by 5 factorial. Here I am pronouncing it I, but it is called iota. So this is what mean is iota. Then in the next step, if you see here, we know the values of, as we have learnt in our secondary higher classes, that means iota is equals to root over minus 1. And similarly, if I go for the iota square, the value will be, I can write it as iota into iota, which is equals to root over minus 1 and into root over minus 1, or simply I can write it as iota square. I can simply write it as minus 1 root over whole square. On cancel outing, I got the value of iota square as minus 1. And similarly for iota cube, just split out the power values as iota square, the values which we have already. So we have to split the value of power in the basis of what we got in the previous steps. So iota square into iota to the power of 1. So iota square value is minus 1 and iota 1 value is minus 1. So I just write the value as iota 1, which is equals to minus iota. And similarly for iota to the power of 4, I just split out the value as iota square into iota square. So the value of iota square is minus 1 into minus 1, which is equals to 1. And similarly we will go for the iota to the power of 5. So I can write it as iota to the power of 3 into iota to the power of 2. And iota to the power of 3 value is minus iota. And iota square value is minus 1. So minus will get cancelled out and the left out value is iota. So like this we can get the values of iota. So then substitute the values. So here I just substituted the value of I square, as we got the I square value as minus 1. So here minus 1 into x square, which is nothing but x square only. So I have written x square upon 2 factorial. Then iota cube value, if you see here, the iota cube value is minus I. So I have written minus I into x cube upon 3 factorial. And then iota to the power of 4, we got the value as 1. So 1 into x to the power of 4 is x to the power of 4 by 4 factorial plus iota to the power of 5, I got the value as iota. So iota into x to the power of 5 upon 5 factorial and so on. This is what the equation we got here. And then in the next step we will separate the a numeral value and the iota value. If you see here, we have here one iota value, and this is also our iota value which is multiplied here, and this is also one of the iota value. Now separate these values and get only the value where the iota, that means I, is not multiplied. Just separate out. So after separating, this is what the equation we will get. And then here is the equation which is written. That means here I have taken, if you see here, every term is multiplied with iota, so I have taken the iota value outside. Then the equation is like this. If you see here, by the Taylor series, this is our cos cos x value, and this is our sin x value. So I can write it as e to the power of ix is equals to cos x, then plus I is there presented here, so here the I is presented, then into sin x. So this is what we got, a formula for the hyperbolic functions, which will be used in solving the proof values. So now, in the same way as we have seen in the equation 1 which we have considered, in the same way as we have considered the value of x as ix, in the similar way we will also consider here again, wait a minute, again we will consider, again put the value of x as minus ix. So similarly we will substitute the value of minus ix in place of x, and we will write the equation 1 as like this. So if you see here, the first equation is this, the same way I have written, which is nothing but in place of x I just written as minus ix, then the value will becomes e to the power of minus ix is equals to 1 minus ix, then again here I can write it as plus of minus x square whole square, and so on. So this is what I have written here. Sorry, yes, here I have written. Then after writing this value, I just multiplied the power values in the individual terms. That means e to the power of minus ix is equals to 1, plus minus will be minus ix, then I square value. So here is nothing but minus of I square, which is equals to I square only. So we got the I square here into x square upon 2 factorial, and then minus. So similarly for I to the power minus I to the power of 3 will be, if you multiply this value as minus I into minus I into minus I, we get the value as minus I only. So I have written here minus I cube x cube by 3 factorial, and similarly for minus I to the power of 4 here, which is nothing but minus I square into minus I square. So here I got the minus I square value is I square into I square, so the positive one. So I to the power of 4 x to the power of 4 by 4 factorial, and similarly for the, I have written for the minus I x to the power of 5 upon 5 factorial. So I have written this much. Then after writing, as I have done here, if you see here, I just separated out the values. Similarly here also I have separated the I term which is not multiplied, the values I have written first, then the term where the I is multiplied, so I have separated this one as like this. Then after, if you see the values again, this is our cos x value. So this is our cos x value, and here we got the minus x, since here it is present minus x values, so I have taken minus x. So this is our sin x value, then I can write it as cos x minus I sin x. So this is one of the identity we can use in the proof sums in the hyperbolic function. Then From here onwards, we have to solve some more steps to get the sum of the formulas of hyperbolic function. So we got the second and third equation. So this is our third equation, and if you see here, this is our second equation. We can say this is as our second equation. So here we will add the second and third equation. So adding equation 2 and 3. So on adding these two equations, also we will subtract these two equations. Let us add first. So on adding we will get, let me write the second equation here as e to the power of ix is equals to cos x plus I sin x. This is what we got in the second equation. So this is our second equation. Just I have written for the clarification to solve the values. So let's add these two. So e to the power of ix plus e to the power of minus ix is equals to, the second equation's value is cos x plus I sin x, then plus again cos x minus I sin x. So this is what we got here. So here the plus I sin x and minus I sin x will get cancelled out, and the left out value will be e to the power of ix and plus e to the power of minus ix is equals to, so cos x plus cos x will be 2 cos x, and then I can write it as cos x value will be e to the power of ix plus e to the power of minus x upon 2, which is nothing but the hyperbolic function value which we have got. The same way we got the fourth one. So consider this is as a fourth one. Now similarly we will subtract the equation 2 and 3. So write it here. Again subtract equation. So equation 3 from equation 2. So from equation, so we can subtract the equation 3 from 2. We get e to the power of ix minus e to the power of minus x is equals to cos x plus I sin x, and then minus cos x minus I sin x. So this is what we got here, and let's solve this one. So if you solve this one, the cos x and the minus cos x will get cancelled out, and the left out value will be e to the power of ix minus e to the power of minus x, which is equals to 2I sin x. So then I get the value as sin x. So here I can write it as sin x will be equal to e to the power of ix minus e to the power of minus x upon 2. So this is our fifth equation. So as we have got the sin x and then cos x, and also we got the value for e to the power of minus ix value, and here I have written, but the actual one was here, e to the power of ix is equals to cos x plus I sin x. So this is what we got here. There are some more identities which we have to study is some more identity. So let me write it as result. So here some results are there. That means the first one is sine, let me write with this. So sine hyperbolic ix will be equal to I of sin x. So you can also prove this one by using the hyperbolic function formula, which is nothing but we can write it as sine hyperbolic x. Instead of x I will write it as ix. So in the same form, e to the power of x, in place of x I will write as ix minus e to the power of minus x, that means ix upon 2. Then sorry, I think here we have to get the I value. Yes. So here if I multiply sine hyperbolic ix will be equal to e to the power of ix minus e to the power of minus ix. On multiplying and dividing I, we can write it as sine hyperbolic ix will be equal to I sine x, since we got the sine hyperbolic x value. In place of x I have written ix. Similarly, as I will write directly the results, you can prove those results. So the second one is cos hyperbolic ix, which is equals to cos x, and then the third one is tan hyperbolic ix, which is equals to I tan x. I will provide the notes to you so that you can get the proof of these values. And the fourth one is sine ix will also equals to of I sine hyperbolic x. So this is what we got the value. So these are not, so these are the hyperbolic value and these are the terms of trigonometric values. Then the fifth one is cos ix is equals to cos hyperbolic x. If I have mistakenly pronounced it as somewhere hyperbolic x, kindly check it out, that here we get the hyperbolic function and the value also we get the trigonometric functions. And then the sixth one is tan ix, which is equals to I tan x. You will get the notes of these proofs, and then again we will do some proof sums of these of this topic, related topic. So let's write the question first. So if we write the question first, the first one is given cos hyperbolic x plus sine hyperbolic x to the power of n will be equal to cos hyperbolic nx plus sine hyperbolic nx. So this is what the question is given to prove out. So let's prove by using the LHS side. So we will prove the sum by using the LHS side. So the given value is cos hyperbolic x plus sine hyperbolic x to the power n. So we know the formulas of cos hyperbolic x and sine hyperbolic x. Then I can write it as e to the power of x plus e to the power of minus x upon 2. Then plus e to the power of x minus e to the power of minus x upon 2 whole to the power of n. Then similarly, on solving these, I can write it as e to the power of x plus e to the power of minus x plus e to the power of x minus e to the power of minus x upon 2 to the power of n. Then I can cancel out these values. So I can cancel out these values here. That means plus e to the power of minus x and minus of e to the power of minus x will get cancelled out, and then 2 e to the power of x upon 2 to the power n. So here also again the two values get cancelled out and the remaining one will be e to the power of x to the power n, which will be written as e to the power of nx. Now in the same way we will prove for the right hand side we have to get the same value only. So in the right hand side it is given that cos hyperbolic nx plus sine hyperbolic nx. So let's prove this sum by using the hyperbolic functions formula only. E to the power of nx plus e to the power of minus nx upon 2 plus e to the power of nx minus e to the power of minus nx upon 2. Then on solving this, we can write it as e to the power of nx plus e to the power of minus nx plus e to the power of nx minus e to the power of minus nx upon 2. So here the positive and negative term values will get cancelled out, and the remaining value will be 2 e to the power nx upon 2. Now here also again we will cancel these two values, and we got the value as e to the power of nx. So hence it is proved that LHS is equals to RHS. So this is what we got the value. So first question we solved here. Now we will go for the other question, that is the second question is given that question 2. So cos hyperbolic x upon 1 minus tan hyperbolic x plus sin hyperbolic x upon 1 minus cot hyperbolic x. So this is what we have here. Then sin hyperbolic x plus cos hyperbolic x, where here x is not equals to 0. Here it is given the condition that x is not equals to 0. So we will prove this sum from the left hand side. So by using the left hand side value, I can write it here as the given value. Let us write the first one, cos hyperbolic x upon 1 minus tan hyperbolic x, then plus sin hyperbolic x upon 1 minus cot hyperbolic x. So this is what we have here. Now let's solve this one. As here we can remove the tan and cot values by using the formula called tan theta is equals to sin theta upon cos theta. And similarly for cot theta, we can follow the formula of cos theta upon sin theta. So by using these values, I can solve the right hand side value. That means I can write cos hyperbolic x upon 1 minus. So here we have tan hyperbolic x. So we will follow this identity. That means sin hyperbolic x upon cos hyperbolic x, then plus sin hyperbolic x upon, let's write the value of cot theta. That means cos hyperbolic x upon sin hyperbolic x. So on solving the denominator side values, I get it as cos hyperbolic x upon cos hyperbolic x minus sin hyperbolic x by cos hyperbolic x. And similarly for this also I can write it as sin hyperbolic x upon sin hyperbolic x minus cos hyperbolic x upon sin hyperbolic x. So just on reciprocating these values, I can write it as cos hyperbolic square x by cos hyperbolic x minus sin hyperbolic x. And again here this value will get multiplied here, then I can write it as sin hyperbolic square x upon sin hyperbolic x minus cos hyperbolic x. Then here I can also write it as, just to by rearranging the values, I can write it as cos hyperbolic x minus sin hyperbolic x minus of sin hyperbolic square x upon then cos hyperbolic x plus sin hyperbolic x. So just I have written like this, so here it will be negative. So again we can follow the a square minus b square formula. That means a plus b and a minus b. In this form I can write this one as cos hyperbolic x minus sin hyperbolic x, and again cos hyperbolic x plus sin hyperbolic x upon cos hyperbolic x minus sin hyperbolic x. Then these two values will get cancelled out, so the remaining will be cos hyperbolic x plus sin hyperbolic x. Then sin hyperbolic x the same way, only hyperbolic x, which is our right hand side value. If you check it out, we got the right hand side value. So this is our second question. So now we will go for the third question, that is given that the third question is given that tan hyperbolic ln x is equals to x square minus 1 upon x square plus 1. So this is the question given to us to prove this one. In order to prove this, we know the tan hyperbolic x formula. So let's write that one. So tan hyperbolic x is equals to, so tan hyperbolic x is equals to e to the power of x minus e to the power of minus x upon e to the power of x plus e to the power of minus x. And similarly, in place of x, so replace ln in place of x. So on replacing, I can write it as tan hyperbolic ln x is equals to e to the power of ln x minus e to the power of minus ln x upon e to the power of ln x plus e to the power of minus ln x. Then we know as e to the power of ln a will be a ln e, which will be a, or simply we can cancel out this value and we can get the value as a. So which is equal to a. Then we can write it as tan hyperbolic ln x is equals to, on cancel outing these values, I can write it as x minus of, so here it is in the form of minus e to the power of minus ln x. So if I cancel out these values, still it is in the form of minus x value. So I can write this as 1 by x. So 1 upon x by x plus 1 upon x. Now in this step, we will multiply and divide the x in the numerator and the denominator to get the RHS side. Just write it down as tan hyperbolic ln x is equals to, multiply x in the numerator as well as in the denominator, 1 upon x and divided by x plus 1 by x. And then on multiplying, we got the tan hyperbolic ln x is equals to x square. See here, x square minus x upon x divided by x square plus x by x. So x will get cancelled out and remain as 1. So x square minus 1 upon x square plus 1. Okay, so this is what, if you see here, we got the answer. So these are the three questions which we have solved. I will give 2 more questions for your homework, and I will also provide those answers in the description box. Kindly check it out. So the homework questions are, the first one is 1 plus tan hyperbolic x upon 1 minus tan hyperbolic x will be equal to e to the power of 2x. And then the next question for homework is tan hyperbolic x upon sec hyperbolic x minus 1 and then plus tan hyperbolic x upon sec hyperbolic x plus 1, which is equals to minus 2 cosec hyperbolic x. So that's it for today. Thank you.